We've already demonstrated some of the basic tools that Autodesk Inventor has for sheet metal design. But in this video, I'm going to take you through a little bit more robust of a part and introduce some design concepts that you will want to use when you're designing your own sheet metal parts. Welcome back to Practical AutoCAD and Inventor, your source for practical solutions to your problems with AutoCAD and Autodesk Inventor. If you like these videos, please like and subscribe so you will be notified whenever new videos are published. Also, if you have any questions you would like me to answer, please leave a comment below. Now, on with the video. In order to demonstrate some of the other tools and design considerations when using sheet metal in Autodesk Inventor, I'm going to be modeling this part. It's a Simpson Strong Tie BC4. It's a beam connector for two beams that are both 4 inches nominally wide, which is 3.5 inches in reality. On the Simpson Strong Tie site, we can see it's right here. It's this BCS post cap, and it's this one right here, W1, W2, L1, L2, height 1, height 2. This one is the BC4. It's similar to the BC46 and the BC6. The one that we're going to be doing is this one right here. So we'll see that these dimensions W1, W2, L1, L2, H1, and H2 are all the same. So I'll be able to put those in there and make it a little bit more consistent and go through it a little bit quickly. A couple things to note here is when we look at this, both W1 and W2 are inside dimensions. So it's supposed to be 3 9/16 on the inside dimension so that you can still fit your 3.5 inch beam inside of there. If they made it exactly 3.5 and there was something, up with the manufacturing with the beam, which often happens, it might actually be a little bit thicker than that, it wouldn't quite work. So that's going to be what we're working with there. In order to do so, we also need to know the locations of the nail holes, and this bigger hole here is a manufacturing hole. It's not really meant to be used for bolts or anything. It's just a hole that they use while they're manufacturing it for locating purposes. But I'll be showing you how to put all of these holes in. However, there's no information on the website about the diameters of those holes and where they're located, so I've made a few measurements on my own, and when I look at it here in Inventor, this is what I've come up with. So this is what our flange will look like, and I've got these dimensions in here just so that we can refer to them in a different drawing. So we're going to start off by doing the same thing that we've always done. I'm going to say File, and I want a new part. The part that I want is a sheet metal part, so I'll say Create that. And as before, we will also begin with creating our sheet metal defaults. So this time, this part is 18 gauge galvanized steel. And under the material here, we're going to go ahead and choose steel galvanized. We'll change the thickness here to 0.0516. which is the thickness for galvanized sheet metal that is 18 gauge in thickness there. On the other two tabs here, we're going to make two changes. We're going to change this from a straight relief shape to a round relief shape, and the same thing on the corner. We're going to change that from trim to bend to round. And you'll see why when we get closer to the end, it's going to make things a little bit better. So we'll choose Save, and we will double click here to make that one current. And now you can see that it's current and it's ready to go. So now that I'm ready to begin working, I'm going to start a new sketch, and I'm going to start with the base of this. We'll do the flanges in a moment. So I'll click here on the base. I'm going to rotate my view cube so it's upright. And then if we go back to the model itself, the base here is W1 by W2, okay? So again, W1 and W2 are both 3 9/16, okay? I'm going to go ahead and set them up, even though they're equal, I'm going to set them up with a W1 and a W2 dimension on each one. Now, instead of just starting anywhere, One of the design considerations, because this thing is somewhat symmetrical, is I'm going to center my design on the origin here. So I'll start off with a rectangle, and I will put it in. Again, you just got to get it approximately the right size and shape. Okay, I'm going to come in and say, okay, I want this to be horizontal with the center, and I want this one to be vertical with the center. That way it's, you know, it's no matter what I do with the sizes, it's going to be, you know, balanced on that center point. Again, that'll make a difference a little bit later. And then I can come in here and I can say, okay, this dimension right here is going to be W1, which is going to be equal to 3 9/16. And then I'll do the same thing this direction. This one will be W2, which is also equal to 3 9/16. Now, I could have just made those two equal, but this gives me a little more flexibility. Let's say I want to take this model, make an eye part out of it later. By giving them two different dimensions, I'm giving myself a little bit more flexibility here. So I'm going to choose OK on that. This is now fully constrained, and this is all I need for the beginning of this. So I'll choose Finish, and then we will use the Face tool to put that first face in there. So there we go with our first face. Now the second thing that we're going to put in is just one of the flanges. So if we come back here and we look at this, I'll put this flange in first. The length of that flange is L1, okay, and the height of that flange is going to be H1. So if I come back over here now and look at this, I'm going to start that part, and I could make it with a regular flange and put some chamfers on there, and that's perfectly fine. That's what I'm actually going to do on this one. So I'll say I want a flange. On my flange, my height here is going to be that H1 dimension. So if I come down here and I look at H1, that dimension is 3, okay? And then the length of that flange, pardon me if we come back here and look at that, the length of that flange in this case is 2 7/8, okay? So taking a look at this now, when I come in here and I say I'm going to select that, I'll select that corner, and I want my length to be 3, but notice it's the full width of this, which is not what I want. I want it only to be, instead of 3 9/16, I want it to be 2 7/8. So in order to cut that down a little bit, I'm going to hit the little expander for the more options here. And now I can say on this, I don't want the full edge, but I want it to have a width. And that width that I want it to have is 2 7/8. And when I do that, you'll see that it comes in here and it puts that flange in place. And it also puts those little round relief. Remember the round relief that we were looking at earlier? It puts those in there. This part out here is going to end up getting cut off a little bit later, so we can ignore it for now. So that's the beginning of our first flange. Now from here I can put in my chamfers, okay, those corner chamfers. Because again, if we look at the part, it's got corner chamfers, one on each side. And if I go to my other part that I had created here, you can see that I've got them in here. They're at a 45-degree angle, and the distance from the corner to that corner that would be intersect there is actually 1 1/8. I didn't put that dimension in because I put it on the center here. But I can come in now and I can say, okay, oops, back to the other part. If I want to put those corner chamfers in, I'm going to change that value to 1 1/8, and I will put in the 2 corners. So my corners are that one there and that one there. Say OK. And so now I've got my corner chamfers in place. If now I want to come through and put my holes in place, I can do that. So I'm going to start a new sketch, put it on that surface. And I like, one of the tips here that I want you guys to recognize is you can use construction geometry to help align your holes. So I'm going to change to the construction geometry, and I'm just going to draw some lines in, fixing it to the midpoint there and coming down like this. And then I will put in another one that lines up with that endpoint and, you know, goes across like this. So how does this help? Well, by coming in here and putting in a few constraints, like the midpoint of that needs to be at the endpoint there. Now these two endpoints are always going to be exactly the same distance apart. So when I come back in here to put my points in for my holes, I can say there's 1, there's 2, there's 3, there's 4. I don't need to put in any more constraints because they're already constrained to those lines. All I have to do is put in my dimensions. So from here to that one there, I think I had it at 5/8, is that right? If we come back and look here, 1/2 inch and then 1 inch. So this one is 0.5. And then the next one here is 1. These two from the top are 2 1/8 down. And then the width apart on those is 2 inches. So again, by doing this, notice that I've got everything ready to go here. This is telling me, oh, I missed that one right there. That should have a coincident constraint with the endpoint. I missed that one. So we are now fully constrained. So now I can save this, finish the sketch, and I can put my holes in. Now, again, this is going to be a larger hole than these other 3, but I'll go ahead and use the hole tool to do that. So if I come in here and say I want to add a hole on here, I'll say here's my hole tool. And I have this tuned up for the larger hole. That larger hole has a diameter first. So I'm just going to hold my shift down and deselect these other 3 that I don't want. So that one's ready to go. The diameter I already have set up as a 1/2 inch, so I can say OK. And then again, because I included more information in there, I'm going to go ahead and turn my visibility back on. I'll use the hole tool again to put those others in. The others need to have a diameter of, I'm going to do 3/16, 0.1875. Oops. 0.1875. That's because in the literature, if we look at the literature here, the literature says that they are to be installed with 0.162 by 3.5 inch nail. That's a 16 penny nail. And a 16 penny nail has a diameter from 0.162 to 0.165. The hole has to be a little bit bigger than that. Otherwise you won't be able to get the nail through, or it'll scrape off all the coating or whatever it happens to be. So 0.1875, 3/16 is the appropriate size for that. So now coming back to Inventor, we've got those 3 holes in place. We can say OK. And now that we're done with that one, we could turn this off if we want, but I'm going to leave it on just for now, just so that we can see that we're going to be able to reuse this information a little bit later. Now, rather than do all of this geometry on the other side, here's another design tip. You can use some of your patterning tools. All right. For example, I've got a mirror tool here. And if you think back to the beginning, I centered this object on my origin here. So if I make this visible, for example, I can come in now and I can say I want to mirror the flange, the chamfers, and the holes along this mirror plane. And when I do, it will automatically come in and put the same cuts in on that one. So doing it here saves a lot of time, because now I can just mirror it across, and no matter what I do, it'll always still work. So I'm going to come in here and I'm going to turn the visibility off on this one. Now for the other flanges go down. I can do the same thing that I did on this one. And so that same process, I'll say I want a flange. In this case, it's going to go down this direction. And I want all of those same settings. So it's still 3, and it's still a width, and the width is still 2 7/8. So I can say OK there. And then I can put my chamfers in. So that same process here for my corner chamfers. Notice that it retains those values as default values to kind of help you out a little bit here. Say OK on that one. And now I can put in a new sketch on that surface, and I'm going to rotate it back here. Remember, I left these up for a reason, and the reason that I left those up is so that I can come in and I can use those dimensions again. So I can come in here now and I can say from here, you know, like this, and then across this way, and then I need to put in a couple of constraints. So that endpoint needs to be at the midpoint, and that midpoint needs to be at the midpoint. So now it's all, you know, as far as size and stuff goes. I can put my points in. So I need a point about there, at this endpoint here, and this endpoint here. And now when it's time to put my dimensions in, I can say that I want this dimension to be equal to that one. I want this dimension to be equal to that one. So I'm just reusing that information again. No sense in turning that off. What did I do here? Oh, I think when I put this one in right here, I put it at the midpoint. So let me put that one back in here so that it's not at the midpoint. So dimension from there to there is equal to that. And then dimension from there to there is equal to that one. And then this dimension is equal to that one. So now again, I'm fully constrained. I didn't have to go back and remember any of those dimensions. Finish that. At this point, I'm done with the first set, so I can turn this visibility off. And now I can just do the same thing with my holes on this one. So I'll do my holes again. This time it's going to give me my smaller holes first, but to keep things consistent, I'm going to say 0.5 here so that my big hole comes in first. I'll deselect these other 3, say OK, make this one visible again, and then put the rest of my holes back in. So same thing, hole, my diameter here this time is going to be 3/16. Again, just for consistency purposes. And say OK. And we're done with that sketch, so we can turn the visibility off on that one. And then just as we did before, I'm going to mirror all of those features to the other side. So using my mirror tool, I want the flange, I want the chamfers, I want the holes. Okay. My mirror plane this time is that YZ plane, so I can just pick it straight away right here. It's automatically going to mirror that everything across. So the only thing that I'm left with now is this little tab that sticks out. And in order to get rid of that, we're just going to do basically a cut feature. Okay, so if I go back to my base view here, I'm going to come in and I'm going to start a new sketch on that surface. And we'll just pick this one right here. What I want to get rid of is all of this on the upper corner. So just like we would do in regular Inventor, I'm going to project that, and then all of these edges as well. I don't need to get the whole thing, just those edges. And then I'm going to draw a line that is tangent. It's going to be tangent to that one, and it's going to be tangent to this one. Okay, so I do need to apply that tangent constraint down here. So tangent there. And so now notice that this is fully constrained. There's no dimensions on it, but all of this is, you know, already defined. If by telling that one that it's tangent, I'm good to go. I don't need to repeat that on the other ones. So now I can just take and I can use that right there, and I can do a cut on this. So I can say, okay, let's go ahead and do a cut. I'm going to get rid of that portion there, say okay. It got rid of it there. Notice how nice and clean that is. And now in order to get that the rest of the way around, I can just do a circular pattern. The thing that I want to pattern is that cut, okay? And then my rotational axis in this case is going to be my y-axis. So I can pick that straight away here, and they need 4 of them. And then I say okay, there's 90 degrees, filling up 360 degrees, so that fills up those 4. And then that cleans everything else up. So now as I save this, that's all good to go. You can go ahead and you can create your flat pattern from there. You could, finish this all out and make it all look perfect. Go back to your folded part. So that is just a little bit more about using Inventor with your sheet metal, and a couple of more advanced kind of thought ways of using the tool in ways that maybe you didn't consider.